चलिए जी, लेट्स गेट स्टार्टेड। पहला क्वेश्चन देखते हैं, बहुत इजी क्वेश्चन से स्टार्ट करेंगे। इट इज ठीक है। तो पहला क्वेश्चन है कि आपको इनपुट में दिया रहेगा एक एरे। ठीक है, सो यू आर गिवन एन एरे एज एन इनपुट with a condition that the elements of this array are going to be either 0 or 1 or 2. Okay, so the given array will contain only 0, 1 and 2 as input. So for example, the array can be 1 1 2 1 1 0 0 2, something like that. Okay, now your task is to return me this array, but you have to sort it. Okay, so you have to return me the sorted array. Okay, now how will a sorted array look like? Sorted array will look like there are 2 zeros, then there are 4 ones, and then there are 2 twos. Okay, so this is going to be your sorted array. Okay ji, so we will be given this input and we want this output. Okay, so first of all, let's think about it this way. सबसे पहले जो ब्रूट फोर्स वे मेरे दिमाग में आता है वो होता है n log n, राइट? यू जस्ट सॉर्ट इट विदाउट थिंकिंग कि क्या चल रहा है, यू जस्ट सॉर्ट इट, राइट? सो n log n के अंदर अपन लोग ये काम कर सकते हैं। उसके बाद सेकंड अप्रोच, अपन लोग हैश मैप भी यूज कर सकते हैं। ठीक है, हैश मैप क्या होता है? हैश मैप या हैश टेबल काउंटर की तरह काम करेगा। आप 3 वेरिएबल बना लो, a b and c, या फिर काम ऐसे बना लेते हैं, ज्यादा मीनिंगफुल वेरिएबल बना लेते हैं, काउंट 0, काउंट 1 एंड काउंट 2। ठीक है, or let's iterate the list one by one. Let's try to figure out how many zeros and how many ones are there. Okay, so number of zeros will be 2, number of 1 will be 4, and number of 2 will be 2. Now that you have this number, it's easy, right? अब वापस से लिस्ट को ट्रैवर्स करो और जितने जीरो है उन प्लेस पे जीरो लगा दो, उसके बाद नंबर ऑफ वंस लिख दो, उसके बाद नंबर ऑफ टूज लिख दो, करेक्ट? And there you have your sorted array. This is also a valid approach, correct? अब मुद्दा ये है कि जब मैं हैश मैप यूज कर रहा हूं तो आई एम एक्चुअली यूजिंग ओएन अमाउंट ऑफ टाइम एंड आई एम ऑल्सो यूजिंग ओएन अमाउंट ऑफ स्पेस. Space, my friend, is a costly business, right? We'll try to reduce the cost as much as possible. Both time and space are actually a cost. So अपन लोग को ये कॉस्ट रिमूव करनी है. हाउ कैन वी डू दैट? एंड द प्रॉब्लम इज, जो दिक्कत अपने को है वो ये है कि दिस इज यूजिंग ओ एन अमाउंट ऑफ स्पेस एंड वी डू नॉट वांट दैट. अपने को ये तो नहीं चाहिए. ठीक है, तो एक काम करते हैं, लेट्स स्टार्ट टू डू वन इंटरेस्टिंग थिंग. अपने को थोड़ा सा स्मार्ट बिजनेस करना है. अब देखते हैं स्मार्ट बिजनेस कैसे करें. ठीक है, सो लेट्स कीप द एरियाज. ठीक है, तो यार अपने को ना कुछ सेग्रीगेशन चाहिए कि इस पर्टिकुलर पार्ट के अंदर जीरोस हैं, इस पर्टिकुलर पार्ट के अंदर वंस हैं, और इस पर्टिकुलर पार्ट के अंदर टू है. हम लोग को इस तरह का कुछ सेग्रीगेशन चाहिए अपने एरे के अंदर. क्या मैं अपनी एरे को इस तरह से सेग्रीगेट कर सकता हूँ कि जितने भी जीरोस मिले वो सबसे आगे जाएं, जितने भी वन मिले वो पीछे जाएं, बीच में जाएं, और जितने भी टू मिले वो आगे सबसे लास्ट में जाए. समथिंग लाइक एन इंसर्शन सॉर्ट, नॉट कंप्लीटली बट समथिंग लाइक दैट. ठीक है, तो अभी काम करते हैं. अब यहां से सोचते हैं कि कैसे कर सकते हैं. तो मेरा जो जीरोथ एलिमेंट होगा वो तो यहाँ पे आएगा, उसको बोल देते हैं P0. और मेरा जो सेकंड एलिमेंट है, मतलब जो टूज हैं, वो पीछे से स्टार्ट होंगे, तो इसको बोल देते हैं P2. अब एक काम करते हैं, अब अपने को P1 बताना है कि P1 कहाँ पे होगा. अपने को पता नहीं ना P1 कहाँ पे होगा, तो एक काम करते हैं, रैंडमली उसको बोल देते हैं कि भैया P1 भी एक काम करो यहीं से स्टार्ट, क्योंकि ऐसा ऑप्शन हो सकता है कि आपकी पूरी की पूरी एरे के अंदर जीरो हो ही ना. ऐसा हो सकता है ना, करेक्ट? तो अपन एक काम करते हैं, हम लोग 3 वेरिएबल्स बनाएंगे, P0, P1 एंड P2. P0 और P1 को दोनों को स्टार्टिंग इंडेक्स से स्टार्ट कर दीजिए और P2 को लास्ट इंडेक्स से स्टार्ट कर दीजिए. अब यहाँ पे हमारे पास 3 केसेस बनते हैं. ये वाला जो P1 वेरिएबल होगा ना, ये हमारा मूविंग हेड होगा. ठीक है, हमारा जो P1 वेरिएबल होगा ये एक मूविंग हेड होगा, और ये P0 और P2 सेग्रीगेटर की तरह काम करेंगे. जब हमारा कोड कंप्लीट हो जाएगा तो P0 यहाँ पे और P2 यहाँ पे आ जाएगा, और हमको पता है बीच में तो P1 ही है. सो आई एम ट्राइंग टू क्रिएट 3 वेरिएबल्स P0, P1, and P2. And my end goal is to divide the whole array into 3 parts. The first part will contain 0, middle part will contain 1s, and last part will contain 2. Okay, so I'm trying to figure out what will be the ideal location of these segregators. Okay, so I have created these. P0 I have put at the 0th index, and P2 I have put at the last index. This P1 is going to be by moving head, which will keep moving from 0th index to the last index. Now there comes 3 cases. What are the cases? P1 can be 1, P1 can be 0, P1 can be 1, and third, P1 can be 2. Okay, so these are the 3 cases we have, correct? Let's start. So if you get the first index, if you get 1 as the first index, 1 is the first element, you do not really have to do anything. I mean, because P1 will be somewhere around here. So you just increase the value of P1. You say, hey, P1, let's move further. P1 plus plus. Okay. Now you keep on moving further till you get P1 is equals to 1. So this is P1 is equals to 1, and this is also P1 equals to 1. So now I'm here. Now P1 is at this position. But we know that 0 must go to the start of the array, correct? So what will I do? I will swap P0 data with P1 data, correct? I will swap this P0 data with P1 data. So once the swap happens, once the swap is done, 0 will come at the start. Then we have 1 and 1. Then we have 2, 2, 1, 2, 1, correct? And now my P0, now this part is done, right? So P0 will come to the next part. P0 is a segregator kind of thing. So P0 is there. The work of P1 is done as well. So P1 will move to 1 point ahead as well. Correct? Now let's see. So if it is P1 is equals to 0, you swap the value stored at P0 and P1. You increase the value at P0, and you also increase the value of P1. Now comes the last part, last discussion which we want to do, which is for P1 is equals to 2. For P1 is equals to 2, we know that this data must go at the end of the array. Is that right? So what we do is you swap the data of P1 and P2 this time. You swap the data of P1 and P2 this time. And what will happen is this will look something like that. Correct? Now P2 is here and P1 is here, right? So I don't know. Abhi, it's not clear what element came here. It can be 1, it can be 0, it can be 2, it can be any element, right? So should I increase P1? Answer is no, I should not. Why? Because the element which came from behind, the element which came from the back of the array, I don't know what it is. It can be 0, it can be 1, it can be 2 for all I care. Okay. But we are pretty sure that the element which I sent at the back is 2. That means the task of this P2 is done, and I'll move this P2 to P2 minus 1. So it's going to be P2 minus minus. Let's get started with the code. I'm be writing code in a really fast sense, so that we do not end up wasting time on the easy medium question. Okay, let's get started. I'll use this template file only. So I'm going to create void sort 0, 1, 2. I'm going to get what? I'm going to get a vector as input, right? Let's call the vector nums. And since I do not want to create a copy of this vector, I'm going to pass it as a reference. Okay, one more thing. I'm not going to make it as a constant because I'm going to change the value of this one. Okay, so just passing through reference will work because I want to make sure that the values are changing. So I'm going to create 3 variables now. What's that? P0 is equals to 0. P1 is also 0, but P2 is equals to nums.size minus 1. Correct, guys? Now, while P1 is less than or equals to P2, while it does not reach the P2, the second segregator, What will I do is I will write a switch statement, nums of P1. Now there can be three cases, okay? So it can be case 0, it can be case 1, and it can be case 2. These are the only three possibilities, correct? There cannot be any other possibility. If it is 0, what I'm going to do is I'm going to swap the data which is placed at P0 and data which is placed at P1, okay? So I'm going to swap P0 and nums P1, okay? What I'll do next is I'll increase the value of P0 plus plus. I'll also increase the value of P1 and I'll break from the loop. In case of 1, we already know that it's on the right place. So I'll just increase P1 and I'll break. Nothing else. In case of 2, as we discussed, we are going to swap the data between nums P1 and nums P2. But this time, since we do not know whether P1 is 2 or 1 or 0, that's why what we are going to do is we are going to just reduce P2 to minus minus and our work is done. Okay. Now that this work is done, your data manipulation is already done. Okay. So one more thing, when you are in front of your interviewer and you are writing code, you have to make sure that every variable name that you're creating is crisp clear, right? So it does not matter. I do not really care about the people who say that they can write code in one swap, or who can write a really small piece of code in just one line, congested code. I do not like that. Ideally, when you're writing for a big company, okay, ideally when you're writing the code for a big company or any company for that matter, there are a lot of people who are writing the code with you. Okay, and at that point of time, it's very important, it's utmost important that you make sure that whatever piece of code you're writing is understandable by other person as well. So do not try to write difficult code. Try to write as simple code as possible. You can take as many lines as possible. Naming of the variables should be crisp clear, very crisp clear. Okay. So that's the one thing which I want to pressure a lot. Just make sure that your code is very crisp and clear. The moment your interviewer start reading this, he should understand what's happening. If he does not understand your code, he'll end up thinking that you have not written the right code, or maybe he'll get confused, or maybe he'll get irritated because he's taking interviews back to back. So just make sure that function name, variable name is crisp clear. I mean, it gives correct idea of what exactly is happening, right? And you can take as many lines as possible. Just make sure that the code is clean. It's not dirty. Okay. Anyway, so this was the first question, guys. Let's jump to the second question. Okay, for this question, I'm not going to do the code, but I'll just explain what's happening. Okay, so this is an easy question, but I'll just explain you what's happening. Let's read the statement and then see what's happening. So here's the question, guys. It says that you are given an m cross an integer matrix, right? You are given an integer matrix of size m cross n. If an element is 0, if a particular element is 0, set its entire row and entire column to 0 and return that matrix. What does that mean? That means that look at this particular element. It's 0, right? And if it is 0, what you have to do is you have to set the entire row and entire column to 0 and return the updated matrix. Okay. Now you have to make sure that this, I mean, you just have to do that. It sounds simple, right? It's quite simple. So let's see it here. I'll try to explain it to you guys here. So let's say this is how your matrix look like. 1, 2, 3, 4, 0, 0, 0, 3, 4, 0, 9, 0, 6, 4, 8. Okay, let's see that. Let's just say that this is your matrix. Okay. Now what you're going to do is you're going to find, I mean, I'm first telling you the brute force approach, right? What's going to happen is you're going to find the first 0, right? And what you'll do is you'll try to set the entire row an entire column as what? 0. Okay. So for the first solution, I mean, if it is an n cross n matrix, how much time did you take for this one particular operation? You took O of m plus n for a single update, correct? Will it work? Will it work? Answer is no, right? Because why? It's going to give TLE. It's going to give TLE. TLE stands for time limit error. What do you mean by time limit error? Let's say somewhere I have stored all the positions of zeros. For example, this was 0, this was 0, this was 0. So 1, 1 is 0, 2, 1 is 0, 3, 1 is 0, and what's that? 3, 2 is 0, and 1, 3 is 0. Okay, so let's say these are the locations of zeros, right? And you go to every particular index and you try to set the row and column to 0. So let's say the total number of zeros in this particular matrix is k. So the total amount of time which you're going to spend is equals to k into m plus n, correct? What's the worst case time complexity that can happen? The value of k can be 1, can be 0, and it can be n square, correct? It can be n square, not even n square, I'll say m into n, correct? So the time complexity becomes m into n square, oh my bad, not square, m into n into m plus n. Is that right? So let's just assume that m and n are equal. So in that case, it becomes n square into 2n, which is 3n square. It's a real, not 3n, oh my bad, it's not 3n square, it's 3n cube, okay? 2n cube. So this is a cubic time complexity. It's a really bad one, right? We do not want that. So what should we do? How should we reduce the number of operations which we are committing? What we are going to do is, let's iterate this whole array. And whenever you find a 0, okay, whenever you find a 0, what you're going to do is you're going to mark this particular line, mark this particular row as true, and mark this particular column as true. What we are going to do is whenever we find a 0, okay, we make true to the row and we make true to the column. Let's say I find it on the first row and first column. So I'll make this particular element true, and I also make this particular element true. I found it here, make this true. This is already true, make this true. I find here, make this true, and make this true, right? For this one, make this true and make this true. So these are the only two false positions I got. Now what you have to do is just iterate it one more time. And for any element, if you found that this is true and this is true, right? Now iterate it all over again. So this is your array. And it has something called false, true, 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 and false, true, true, true. Okay. Now, this particular element, should I change it or not? No, because both the row and column is giving me false. In that case, this is going to be 1. This is false. This is true. Should I make it 0? Yes, right? It's going to be 0, 0, 0, and so on. Okay, let's move to the next question. So what's happening is, let's just see. So you must know that when you are using, when you're searching in a sorted matrix, right? I have to give a little context, okay? So what you do is you start from this particular element, top right, right? And you take the decision whether I have to go here or whether you have to go there on the basis of whether the target element which you're searching for is less than the current element. I'll call it CI, greater than the current element, or equals to the current, right? If the target element is less than CI, what you do? If the target element is less than CI, what you do? You totally abandon this row and you go to the left side, okay? Basically choosing this particular row. If the target is greater than the current element, you go to the bottom and abandon this row, okay? And finally, if you get the target, you just say, hey, I just found it, so go ahead and return true, okay? So that's what you do, okay? So what you do is you start with two variables. You create two variables. One is R and another one is C. Okay, so R is 0 and C is equals to the size of the column. Okay, so it's matrix 0 dot size, that is the value of columns, minus 1. So you start with the bottom right and you try to go from C greater than equals to 0, R less than equals to rho, and you try to move. So there are three conditions possible. Either the target is less than the current element, or the target is greater than the current element, or you have found a target. If you have found a target, it's quite simple, just return true. But if the target is less than the current element, you know that in the current row, you will not able to find it. So you reduce the value of column to C minus minus. If the target is greater than the current element, you know that current row is of no use. So you increase the value of R plus plus. Even if after you run this while loop, you do not find the solution, in that case, what you do is you return false. Okay. And one more thing is that you have to make sure that you're doing this particular top interview questions or top 100 like questions, whatever. I mean, you choose what you want to do. Just make sure that you're completing the medium level questions. So there are a bunch of medium level questions over here. Either those questions are part of your question bank, which I'm providing. If you have some more time, do not waste it. Just make sure that you are clicking on any other random question. For example, if I'm just doing binary search, right? Let's say I want to find questions for binary search. So I'll just select the binary search tag. And here are some questions of binary search, right? Search in sorted rotated array, which we can discuss today. First and last position of an element, which we discussed yesterday. Then there is search in a 2D matrix, which we discussed just now. Then there's find a duplicate element and longest increasing. This is dynamic program, so don't do it right away. But yeah, I mean, you get the gist, right? So this is how you have to proceed. Don't waste time. Just make sure you are doing some 7-8 questions every single day. It becomes really important. Chali, let's get started to the next question. So we can solve this search in a sorted rotated array. I think we'll just discuss that, not go into the depth of this one. So the next question which we are going to do is, I think it's the fourth one. Search in sorted rotated. So this is the problem is sorted and rotated array. I just showed it to you on that platform. Where is it? Yeah. So let me clear the context of the problem. The problem is saying that you are given an array. Let's say you have a sorted array: 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say this is your sorted array. Now what I do is I take some elements from the end and I push it at the start. So my array becomes 7, 8, 9, 1, 2, 3, 4, 5, 6. So this, my friend, is your sorted but rotated array. Okay, this is sorted and rotated array. Now I ask you whether a particular element x, remember the x can be 0, the x can be 10,000, the x can be, let's say, 3.5, just for the sake of telling you guys about different cases, and x can be 4 as well. All right, so these are the 4 cases in which x is not, these are the cases in which your answer should return false, and this is the case in which your answer should return true, correct? But these two are edge cases. Why? Because this is less than the first element. I mean, this is less than the minimum element available in the array, and this is the element which is not available because it's more than the maximum element. Then 3.5 is also there. Okay, so this is a standard test. Now I'm going to figure out how I can write my code so that I can solve this problem. So what are the different solutions? The brute force phase linear search, right? You go ahead, you search one by one, and in that case you're going to end up spending O n amount of time, correct? So this is the time complexity in case I do an iterative. But of course, you are not going to do an iterative one, right? You're not going to do you are going to do for an optimized one. You're going to go for an optimized one. And in that case, whenever there is a sorted array, involved, you have to make sure that you think about binary search. You think about, some binary or log level operation. So in that case, their best time case complexity is coming out to be overflog n. Let's think about this problem and how can we solve that. So what we can do is, again, let's try to think about this problem. So let's find an element 8. Okay, let's read the question again. It's question number 33. So this question is saying that you're given an integer array sorted in ascending orders. Now there are some possible rotations. Okay, possible rotation means what can happen is you are taking some elements from the end and you're pushing it in the start, right? So num0 to num k minus 1 at the end and num k to num n minus 1 at the start, right? So for example, the 0, 1, 2, 3, 4, 5, 6, 7 can have 4, 5, 6, 7 at the start and 0, 1, 2 at the end. Now we are going to go ahead and figure out whether a particular element is there or not. Okay? So how can we do that? Chalo, let's think of an algorithm. Okay, let's think of a logical algorithm and how we can move further. So it's going to be sorted. So let's create two variables. One is start, which is 0, and another one is end. Okay, which is how many elements? 3, 6, 9, which is 8. Okay. Okay. So what we do is, सबसे पहले अपन लोग चेक करते हैं, mid निकालते हैं. We calculate mid, which is equals to start plus n by 2. In this case, it's going to be 0 plus 8 by 2. That means 4. So let me write down 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I go to the fourth element, which is this one, and I check whether it is the element which I'm looking for, whether it is equals to x. Answer is no, right? So here comes three conditions, right? X, the middle element, a mid, right? The a mid. It can be equals to the target or x element which I'm looking for. It can be greater than x or it can be less than x, right? These are the only conditions which can happen. Let's think about it from this perspective. What if the element which you found, the element which you found is equals to x? In that case, very simple solution. You return that mid element, right? You return the mid index, and you're done with it. So this is the happy sunny case. Now let's think about this scenario. How do you plan to know? How do you know whether you have to move in the end or in the start? Right? Now the question is whether I should go at the last to find 8 or whether I should go to the front to find 8. We don't know that, right? So let's try to figure it out. If this particular element and this particular element, okay, so you try to see whether the start element, if start element is less than or equals to the middle element, what does that tell you? If your start is less than or equals to the middle element, what does that tell you? It tells you that the first part of the array is sorted and the second part of the array contains the pivot, right? If this condition is true, that means the first segment of your array is sorted. Okay, first part of that element is sorted, first segment is sorted. If this is not the case, that means second segment of the array is sorted. Correct? These are the two conditions I can get. Now, if your first segment is sorted and your second segment is sorted, I have two conditions. Let's try to figure out what happens if your first section is sorted. Okay. So if my first segment is sorted, in that case, again, two conditions. The middle element can be greater than x or middle element can be less than x, right? If your middle element is less than, if your target is less than your middle element, that means right now your code is the first section is sorted. Just do a simple binary search and you can find it on the first section. Otherwise, what you have to do is you have to go to the second section. You know what? Let me write it down so that it gives you more understanding. Okay. So I'm going to put it over here. Just remove this part of code. So this is how the logic is going to work. Okay.
First part, you calculate the middle value. In fact, let me write the code and it will make more sense. This is how the code is going to look like. I mean, this is how it's given to you. Let's write the helper function int search vector int nums int start int end int target. Okay. Now, first condition is check is